Please check 1 through 9. Make sure you have them correct. If you do not, you should be asking me or your neighbor. Number 7, yes. So on number 7, you see that you have a 3 and a 48. 3 is not a perfect square, 48 is not a perfect square. So you should be saying to yourself, self, is there anything I can do there? And you should recognize that both of those divide by 3. So I take out a 3 when I GCF like I always do. Then I put the answers in the middle. 3x squared divided by 3 is x squared. 48 divided by 3 is 16. Then, of course, you should notice that that's a square and that's a square. So it's the square root of the first one, square root of the second one, and then you write it again with a minus sign. Anything else on 1 through 9? Going once. Going twice. Going thrice. Excellent. That means when I give you the pop quiz I'm going to give you at the end of this period, everyone's going to get 100%. Sweet.
Yeah. Now we know this happening.
I know that. That was kind of the point. I know. That was kind of the point. And there is 10 through 13 as soon as 13 shows up. Any questions there? Rihanna. Number 10. Why? If that said 9 minus x, what would it be? Right? You take the square root of the first one, you take the square root of the second one. So why is that a problem? What's the square root of 1/9? There you go. I know it's a fraction. I wrote it. But see, this is the type of thing that makes math teachers want to knock their teeth out with hammers. When you guys come to a question like this and say, I don't know how to do that, when you've just done 30, right? I can't stress this enough to you people. If something works once, it always works. So, if you have a perfect square and a perfect square, you just square root them both. All you got to do is try once in a while. You know that the square root of 9 equals 3. You know that the square root of 1 equals 1. So you should be able to put together that the square root of 1 over 9 is the square root of 1 over the square root of 9, which is 1 over 3. You shouldn't need me to show that to you at this point in your mathematical careers. Should you? Especially since we've already done a unit on radicals and you've written a test on it. Right? I'm not trying to be mean, but at some point, you have to do some math. And I know it sounds weird that I'm stressing about one question, but that's kind of a repeating motif with my math classes. If something looks slightly different, oh, I can't do it. Can't possibly do that one. And you can't do that. So everyone's okay with 10 through 13? All right. And I believe I asked you to do 135, but not 136. So 135 is x plus 2, x minus 2, x plus 1, x minus 1. That is x plus 10. X minus 3. That's 10. X minus y. That's 6. X squared minus 2. That's x. X plus 4 squared. That's x plus 7. X minus 11. That's x minus 5. X minus 3. That's 4. X plus 3. X minus 4. That's x plus 12. X minus 2. Any questions from 1 through 9? Awesome! You guys must have a great Math 10 teacher. He taught you so well you can do all this factoring first try. Sweet! Thanks, guys. It's Friday. I kind of need the old good job, Myers. Because everybody got 100% because nobody needs any of that explained. Wow. Whew. Crazy. Anything there? I'll highlight the final answers because I had to do a little work on that one in my head. Number 10. Yeah, so I actually did number 10 right there. I took out the GCF, right? Because 5, 10, and 120. And 1x and 2y's. So once I factored that out, I divided everything by that, and I got this inside, right? And once I have that inside, I know I have to multiply to negative 24 and add to positive 2. And 6 minus 4 gets me positive 2, and 6 times minus 4 gets me negative 24. And then I had to leave the y's in because I needed a y squared at the end. Cool? Okay. If you only did that step, you'd get half marks. Anything else? Okay, sweet. We're going to save 136 for later because it's a little weird. And we're going to move right on to 137. All right. Now, once again, I remind you, what are these two things? They are factors, right? Because that green binomial is multiplying by that blue binomial, which will give us a new trinomial, yes? And if you multiply that out, if you did it the long way, you would do what most people call FOIL. Or you would recognize that you can do that little shortcut I taught you because it's only x and x, right? Which would make it x squared and then 6 plus 4, which is 10x, and then 6 times 4, which is 24, right? Now, if all of this was gone, then, and you had just that trinomial, of course you would be factoring it, right? And if you factored it, you would get back to this. Is everybody cool? Yeah? Okay. So, this next part right here, what do you have? You have two factors again, yes? So what do you do when you have two factors? You expand it. So expand that for me, however way you're comfortable expanding it. Some of you like to write it all in a long line. Some of you like to stack it the way I showed you. I don't care, but everybody expand that number for me. Or, I'm sorry, expand those two binomials for me. If you still don't know how to do this, you're going to want to pay very close attention right now. Either you've expanded it yourself or you've copied mine out. Either way, you should know that that is our trinomial answer, yes? Now, if all of this side was gone and you just saw that trinomial, you'd want to factor it, right? Now, when it looks like this, we know how to factor it, don't we? When it looks like this, we are looking for a number, or for numbers that do what? When it I'm going to change this to a yellow highlight. When a trinomial looks like the yellow one, how do we factor it? We are looking for two numbers that do what two things? They multiply to 24 and they add to 10, correct? Everybody cool with that? Okay. Now, look at the blue trinomial. What's different about the blue trinomial than the yellow trinomial? Right, the blue trinomial has this coefficient here, yes? The yellow trinomial doesn't. Everybody's cool with that? Okay. So, in the yellow trinomial, we were looking for numbers that multiplied to 24 and to 10, yes? And what number should be written here that isn't? 1. Is everybody cool with that? Okay. Which means down here, isn't 6 times bigger than 1? Right? So up here, we were looking for factors of 24, and we had a 1 there. Right? Well, now everything is 6 times bigger, right? So am I looking for factors of 2 Or am I looking for factors of a number that is 6 times bigger than 2? Right. I got to do this. So now I'm looking for numbers that multiply not to 2, because this is 6 times bigger than 2. So I'm looking for numbers that multiply to negative 12 instead. Is everybody cool with that? Now the next 2 steps are exactly the same. I still need numbers that add to negative 1. Okay? So what are the factors of 12 that will add to negative 1? Is it 1 and 12? Is it 2 and 6? Is it 3 and 4? Right, it's 3 and 4. Which one of those has to be negative in order to get negative 1 when I add them? Right, it's got to be 3 minus 4, correct? Is everyone cool with that? So I know that my polynomial is going to be x plus 3, and the other one is going to be x minus 4, yes? But I'm not really looking for 3 and 4, am I? Because I multiplied that 6 in, didn't I? And at some point when we factor, we have to do division, don't we? Have we done any division yet? No. So let's do some division. What would I divide? The 6 or the 3 and the 4? Or the x or the 3 and the 4? Where do you think the division should take place? Hayden. Pardon? I haven't told you. It's a guess. You got to use your brain. 12 occurred because of what? We multiplied the 6 to get 12, and that got us our 3 and 4. So where do you think the division of 6 should happen? With the 3 and the 4. Now, would you ever leave this fraction? No. What would you make it? 1/2. Would you ever leave this fraction? No. What would you make it? 2/3. Yes? Everyone cool? Okay. Now, look at the original factors. Look at what we have, which I'm going to highlight in yellow. Can you see some similarities? What is the similarity? There's a 1 and a 2. There's a 1 and a 2. There's a 2, 3 and a 2. There's a 3 and a 2. There's a negative or a positive and a negative, right? And there's an x and an x. Now, if you don't want to understand why, then all you have to do for the next step is memorize this. The denominator moves to the front. The denominator moves to the front. And I get 2x plus 1 and 3x minus 2. And then I check. Is 2 times 3 6? Yep. Is 1 times negative 2 negative 2? Yep. So I know that I am right. Everybody cool? Everyone's good? The reason this happens is because what is actually going on here is something we're going to be doing a little later in math. And it's this. X plus 1/2 times x minus 2/3. Now, if I make this equal 0, I can solve these now, yes? Which means x plus 1/2 would have to equal 0, right? and x minus 2/3 would have to equal 0, right? So you will notice that for this to be true, x would equal -1/2, right? And for this, x would equal positive 2/3, yes? Now, if you put that number in there, what's 2 times -1/2? I'll help you out. It's a complicated question. It's -1. What's -1 plus 1? 0. What's 3 times 2/3? 2. What's 2 minus 2? 0. So that's why these numbers work. But all you got to remember is to move the denominator to the front. Everybody good? All right. Now I'm doing something a little weird this time. I'm starting with a gigantic one that looks strange, so when you see you can do that, you can do all the easier ones. Because this is about the time when I realize, damn. So let's look at this. If there was no 20 there, what would I want? I would want to multiply to 10 and add to 33, correct? But there is a 20 there. So since this is 20 times bigger, I can't multiply to 10. I got to multiply to what? 200. Yeah? All right. All right. And what do I have to add to? 33. Some people see it right away, some people don't. Is it 1 and 200? Is it 2 and 100? Is it 4 and 50? Is it 5 and 40? Is it 8 and 25? Yes. So I have b plus 8 and b plus 25, correct? But am I really looking for 8 and 25? No, because I multiplied that 20 through at the beginning. So what do I have to do at the end? Divide it out. Would you ever leave that fraction? What is it? Four tenths? One more lower. 2/5. Would you ever leave that fraction? What is it? 5/4. What do you do with the denominators? Put them to the front. So what's my first one? 5b plus 2. And what's my second one? 4b plus 5. And then, do I have 1 second to check? Is 5 times 4 20? Yes. Is 2 times 5 10? So am I right? Because if the edges are right, the middle's right. Okay, that's a giant one. Big numbers. Could you do it? Pretty easy, right? So let's try it on the next one. What do I do? What do I need to multiply to? It's not 10, because there's a number out front. What do I have to multiply to? 30? -30. Good job. What do I have to add to? -13. Is it 1 and 30? Is it 2 and 15? Yes. 2 minus 15, correct? Right? So what do I write? S plus 2, but it's not really plus 2. What do I got to do? Divide by 3. And s minus 15. But it's not really 15. It's 15 over 3. Then what do I do to every fraction? Simplify if you can. Does that simplify? No. So where does the 3 go? To the front. Does that simplify? To what? Negative 5. S minus 5. Do I have time to check? Yep. What's 3 times 1? 3. So are we right there? Yeah. What's 2 times negative 5? Negative 10. So are we right there? So we're correct. Does everybody have it? Now I start messing with your heads. Look at number 3. Yes, Jordan. Of course. Look at number 3 and tell me what we should do first. The same thing we should always do first. I lie. Wrong word. The same thing we should always try first. I should try a GCF if I can, can't I? Because in number 1, 2, and 3, what's the thing that bothers us? The thing that bothers us is that first coefficient, yes? So we should try to get rid of it. Well, 6 doesn't work, but what does? 3. So I divide all that by 3. Where does the 3 go? Outside brackets. What goes inside the brackets? All of my answers. What's 6 divided by 3? 2x squared. What's 21 divided by 3? 7x. What's 9 divided by 3? 3. Now I can factor that. So I need numbers that multiply to what? 6 and add to what? Negative 7. Is it 1 and 6? Yes, but they must both be what? Negative. Can I forget about this 3? No, all of you will on your test, even though I'm doing this right now. So that is x minus 1, but it's not really minus 1, is it? What is it? It's a half, right? And x minus 6, but it's not really 6. What is it? 6 halves. What do I do with those fractions? If I can. Simplify. Does 1 half simplify? No. So where does the 2 go? To the front. 2x minus 1. Does 6 over 2 simplify? To what? 3. X minus 3. Then I check. Is 2 times x 2? Yes. Is 1 times 3 positive 3? Yes. If I put the 3 back in, will I get back up to that? So are we correct? Yes. Is everybody good? Okay. It's exactly the same thing with one extra step. You had to multiply to find your numbers, and then because you multiplied, you had to divide it out at the end. Because it wasn't really there. Everybody cool? All right. I want to do one more with you, and then I want to give you I want to skip a bunch down to the end of 138. So I want to do one more with you guys, then we're going to skip a bunch, and that's going to be your work for today, okay? So let's do this one. What don't I like there? I don't like the 8. Can I get rid of it with a GCF? No, because 8, 18, and 5 don't work. Can I make it smaller as a GCF? 8 and 18 have a common factor, but 5 doesn't. So I'm stuck with what I have here, yes? So I take my 8 and I multiply it by 5, so I got to multiply to what? Negative 40. And I got to add to what? Negative 18. Is it 1 and 40? Is it 2 and 20? Yes. 2 and 20. Which one has to be positive? 2. Because 2 minus 20, when my computer shows it, will get me my negative 18. So I got P minus 20, but it's not really minus 20. What is it? 20 over 8. And P plus 2, but it's not really plus 2. It's 2 over 8. Then what do I do to those fractions? What's 20 over 8 simplify to? Pardon? 5 over 2. 5 halves. What does 1 over... Morning. We're playing today, right?
Good?
Yeah. Okay. What does 2 over 8 simplify to? 1/4. What do I do with those denominators? Put them to the front. 2p minus 5. 4p plus 1. Then I check. Is 2 times 4, 8? So am I right? Is negative 5 times 1 negative 5? So am I right? Yes. Everybody cool? All right. I am going to... This one, I'm going to put a star by anything that has something that you should do before we do this. You understand what I'm saying? If there's a little star by it, there's a trick. There's a star by 14 because it's a different kind of factoring. There's a star by 15 because it's a different kind of factoring. 16 is where I want to go to next. Now, I've already shown you guys this, but I want to show you again because it's a really useful math tool that you can use for the rest of your mathematical lives. What do you notice about that exponent? It's outside the brackets and it's squared, right? What operation is happening there? Minus. What is that? So isn't this a difference of squares? So doesn't that mean I can do square root of the first one, square root of the second one? Right? Okay. So what is the square root of the first one? Mr. Myers, I don't get what you mean. What's the square root? I don't get it. What if I wrote it this way? A and B. So that makes that a squared minus b squared, yes? What's the square root of a squared? A. And then I write square root of b. And then I just write it again with a minus sign, correct? Now, what is a? It's 2x plus 3, isn't it? So what do I write here instead of a? 2x plus 3. What's b? 4x minus 7. So it was a plus b. So it's a plus what? What's b? 4x minus 7. What's 2x's plus 4x's? 6x. What is 3 take away 7? Negative 4. Everyone cool? Okay. Then I got to do it again. This side is a minus b. What's a? What's a? 2x plus 3. What's b? 4x minus 7. And it's a minus in the middle this time, isn't it? Okay. So what is 2 minus 4x? Negative 2x. And what's 3 minus minus 7? 3 minus minus 7. 10. Everyone cool with that? Everyone cool with that? Okay. Now, what do you notice about 6x and 4. I give you a hint. You can GCF it. What's the GCF there? 2. So that is 2, 3x minus 2, yes? Is there a GCF there? What is it? 2. Negative x plus 5, right? Is there a better way to write negative x plus 5 that looks prettier? Isn't that just 5 minus x? And our goal is to simplify, yes? So do we want 2 and 2 there? What would be simpler than writing 2 times 2? 4. So what this one really is 4, 3x minus 2. And then math guys usually like to write that as 5 minus x. And that, ladies and gentlemen, is the second hardest kind of factoring I can give you in the 10th grade. Do you understand it? It's exactly the same thing, right? So then, look at this one. That's really ugly, correct? But what do you notice about that and that? They're the same, right? So am I allowed to write them differently? Who's in charge of this question? I am. So I'm going to say that that is A and A. And then I rewrite it as A squared plus 8A plus 12. Could you factor that in your sleep? Sure you can, because you need to what? Multiply to what? 12 and add to what? 8. What are the numbers that do that? Is it 1 and 12? It's 6 and 2, right? Are they both positive? So it's going to be A plus 6 and A plus 2, isn't it? But there's no A in the equation, is there? What's A really? 2x plus 7. So what's this really? 2x plus 7 plus 6, yes? What's this really? 2x plus 7 plus 2, right? What is 2x plus, what is 7 plus 6? 13. It's okay, Rihanna. But remind me, I should lend you money at some point in our lives. And what is 7 plus 2? There you go. She's back, baby. And now that one's done. That's the third hardest one I can give you. So I've given you the second hardest one I can give you and the third hardest one I can give you. What's the one I haven't given you? The hardest kind of factoring I can give you in grade 10. And it's not even on this sheet. I'm going to wait. Okay? Your job today, and you have a long time to do it, is you're going to do the rest of 137 and 138. But not before we have a quick look at 136. We're only going to do the first one so you can see how to do it. There's a blank there, yes? Right? If that blank was the number 6, how would you factor that? You would need numbers that multiply to positive 6 and add to 1. Do they exist? What are they? 2 and minus 3 will not multiply to 6. That would multiply to negative 6, wouldn't it? Everybody with me? So it can't be factored if that guy's positive, can it? Everybody with me? What if I made it negative 6? Could I factor that? Then what would it be? Positive 3 minus 2, right? Everybody good? Picking up what I'm putting down? Right? So, the question said, put an integer, which is any number, positive or negative, put an integer in those boxes so you can do it. So, could I put positive 5 there? No, because 5 and 1 won't get me 1, will it? Could I put negative 5 there? No, because 5 and 1 won't get me 1. I could put negative 6 there, because 3 and negative 2, right? Could I put positive 6? No. So right away we see I can't have two positive numbers. So could I put any positive number there? No. So it has to be negative. But we know 5 doesn't work. Would negative 7 work? Why? Because 7 only has two factors, 7 and 1. Will they make 1? No. Will 8 work? 1, 8, 4, 2. Won't work. Will 9 work? One and 9, 3 and 3 won't work, will it? 10, 1 and 10, 2 and 5 won't work. 11, 1 and 11 won't work. 12, why will 12 work? 4 and 3. So right now you guys see 6 will work because it's 2 and 3. 12 will work because it's 3 and 4. What's the next one that's going to work? You missed one. 2, 3, 3, 4, 4, 5. So negative 20 would work. What's the next one that's going to work? Negative 30. 5 and 6. What's the next one that's going to work? (42), 6 and 7. Everybody cool? So what numbers could go in there? Any number, as long as the factors are one apart from each other, right? So that's what you got to do with these blanks. You got to figure out what can go in those spots. Okay? And then dimensions of a rectangle are what? What do I mean when I say what are the dimensions of a rectangle? If I told you the rectangle is 4 by 7, how would you draw it? Length and width, right? Okay, so length, width, and length are the dimensions, aren't they? And how do you find the area? Length times width. So these guys are factors, and the area is a product, isn't it? Well, I've told you that this rectangle has that area. So that's the product. So what am I looking for? The factors. So that would need to be factored. And then this one, you just got to figure out. I'm interested to see if anybody will. Everybody good? 136. The rest of 137 and 138. That's it for a 3-day weekend. And 33 minutes of class time. Should any of you be taking any of this home? No. By no means. Go.